In this third part of the course, where we're thinking about how, if at all, discoveries in moral psychology have consequences for ethics, I'm structuring it by offering you a view. The whole thing, in effect, is an argument for a conclusion. Now, of course, I want to cover a range of different resources that you might use, and I want to provide you with some tools so that you can object, however mistakenly, to the conclusion that I've reached and formulate alternative positions. But the thing is that over the next lecture or so, this is going to become very intricate. We're going to be looking at details about cognitive processes, and we're going to be looking at fairly intricate philosophical arguments, and it's easy, I think, to get lost in the details. A lot of those will turn out to be dead ends. So I thought that some people might like a little preview of where all of this is going. So I'm hoping that this might help some people who like to have sort of the overall picture, the end point in mind, and then work towards it. Although, of course, not everybody does it like that. But the great thing about the recording of lectures is that, you can just skip this one and still be there for some of the others. Now, I want to start here. I'm going to draw an analogy with physical cognition, ethical cognition, physical cognition. So I want to start by asking you, please, to do a little exercise. What I want you to do is to imagine that you're looking down this tube. So this spiral here is actually a tube, and you have the perspective of the arrow. And what you're going to do is shoot in at very high velocity a ball, a little ball. You're going to put it in there, right? This is your pea shooter and it got bent. So what you're going to do is shoot the ball in, right? And round it goes. And what I want you to think about is, what trajectory will the little pea or the ball take as it leaves here, as it leaves the end of the tube? And what I'd ideally like you to do is to take a pen or a pencil and draw a line. Draw a line for me, showing me the trajectory that the ball will take as it executes this tube. Really helpful if you do. I know you don't want to do that. I haven't got a piece of paper. You're so modern, aren't you, without a piece of paper? Take your finger at least and draw a trajectory with your finger for me. How is that finger moving if you're representing how the ball leaves the screen? Good. All right. Now we'll come back to this in a minute. You'll see why it's relevant before. So here's Descartes. Oh, what's Descartes doing here? Well, Descartes starts my favourite book, actually, The World. Unfortunately, this wasn't published. I think this is the essence of Descartes' thinking, much better than the Meditations. Unfortunately, first-year students in philosophy at Warwick have to study the Meditations. I think that's a terrible mistake, because Descartes' project wasn't really about sort of the philosophical forms of scepticism that people are interested in now. That was a sort of hobby, a sideline for Descartes. I think much more the actions here in this book, The World. And Descartes starts that book by saying that concerning light, it's possible for there to be a difference between the sensation that we have of light and what it is in the flame or the sun that we term light. Now this, to us, I take it, it's become so obvious that it seems kind of really weird that anybody would say this. But at the time Descartes was writing, it was far from obvious. And Descartes was using this as the basis for many further claims, where he was moving away from what people thought might have been true on the basis of the senses to a scientific approach. So it's very striking that Descartes starts his whole book, The World, with this observation. There's a difference between the sensation that you have of light and what it is in the flame or the sun that we term light, the thing in itself. Another good illustration of this comes from a different book where Descartes studied the rainbow. So the question was, many people have asked this question, why does the rainbow appear bowed? Why does it appear like a bow? And so what Descartes did here was to try to construct a theory, and I believe this theory is correct actually, although I wasn't able to find really solid confirmation of that. Descartes tried to construct a theory which takes seriously both the phenomenology, the bowedness of the rainbow, and the physics. Put the two things together and you get a good explanation. And of course what we find is that the bowing of the rainbow is not explained by the fact that the world is exactly as it appears to be when you see a rainbow. On the contrary, the discoveries about refraction are something quite different from what you might expect on the basis of sensory perceptions. Descartes says, sensory perceptions do not reveal the natures of physical phenomena. Now that is hardly controversial now. Nobody thinks that we do physics by imagining, you know, how the world seems. What seems obvious to you? Are there self-evident truths that you rely on when you're doing physics? Is that the foundation of your physics? No, it's not. You're not Aristotle. You've been through the Enlightenment. You've had these marvellous scientists. It was a bit of a struggle. It was a bit of a struggle. It took people a while. Even very thoughtful people can find it very difficult to move away from how things appear to them, to recognise that there could be problems with that. But eventually they've done that, and most people now accept that, you know, modern physics works in the way that modern physics does, on the basis of repeatable observations, theories that generate testable predictions, rather than a bunch of people starting from what seems obvious or as if it were a self-evident truth to them. Right? That worked very well for a while, and people did very well at that, but it has its limits. Now here's a second related point. There are broadly perceptual processes, and they influence what seems obvious to you. So it's not just, as Descartes already very insightfully discovered, I suppose, or presented to us, it's not just that how light and other physical phenomena are quite different from how we perceive those things to be. It's also that the way that we judge, even on reflection, things to be, without relying on any theory, so our pre-theoretical but highly reflective judgments, are shaped by these broadly perceptual processes. So this is why I introduced the spiral. The thing about the spiral is that a large number of people will say that the ball will exit the spiral on a spiral trajectory. The ball will exit the spiral on a spiral trajectory. Now, of course, this is wrong. So it turns out, I didn't know this before, but I do know, I haven't done much physics. The ball's supposed to exit on a straight line. So if you drew a straight line with your finger, well done, you got that right. If you drew the spiral, you're like most people, you're like me, you're mistaken. But here's the thing, that mistake is not based on any actual observation, right? It's never happened that something has left a spiral tube and moved in a spiral. So we can't have made the mistake because we've observed this happen, because it doesn't happen. So how is it that so many people, 51% in McCloskey and colleagues study, how is it that so many people make this mistake, right? And when I've asked people in lectures as well, I get around this figure, perhaps more because I've got philosophers in the room, mainly. So why is it that we make this mistake? The answer, I think, is because there are broadly perceptual processes that structure our thinking. There are broadly perceptual processes that structure our thinking, and we have to make an effort to move away from them. Why do I think that? Well, part of the answer is a phenomenon called representational momentum. So let me step back and tell you about that. If we're going to argue that something is a consequence of broadly perceptual processes, this is going to get a bit intricate, a bit detailed. So here's what representational momentum is. So glad you asked. Yep, I'm going to tell you, this is representational momentum. So what you see is a rectangle on the screen, and this is presented statically for 250 milliseconds. Then comes the next image, that one goes away, and you see the same rectangle but just tilted slightly around, 250 milliseconds, so quarter of a second. Here's another quarter of a second, ooh, the rectangle slightly further over, and then you're given a probe. You're given a probe. So same rectangle again, and the question is this rectangle in the same position as the one you previously saw it in or not? Yes or no? Do you think this is the same or do you think this is different? Yeah. So you've got here 3/4 of a second, then a rectangle appears, and you've just got to say same position or different position as the position that you last saw the rectangle in. And what you can see here, I've lined it up so they are basically here, they're basically in the same position, I think. Now, here's the phenomenon, here's representational momentum. Representational momentum is this effect. People tend to be most likely to judge that the rectangles are the same when the rectangle has continued moving on a little bit in the same way that it was moving before it stopped. So I take the term representational momentum to be a kind of joke. It's as if the representation that you have of the rectangle has a bit of momentum and keeps on moving even after the rectangle really has stopped. So what's happening here? Why is there representational momentum? Why is it that when you see, sorry, I've gone the wrong way. When you see this final display, you're inclined to judge that it was the same as you had before when it's moved on a bit rather than when it's exactly the same? Why is it that you think that? Well, the answer, I take it, is this. There are broadly perceptual processes in you which are updating the location of the rectangle. So you're engagement with the perceptual world involves a lot of fragmentary information coming in, perceptual processes that try to fill in the differences. And what you're seeing here is perceptual processes filling in the difference. They're just moving that rectangle on a little bit more for you. Now this is very helpful to us because we can use the phenomenon of representational momentum to study the origins of certain false beliefs about the physical world that people have. So Kozevnikov and Hegarty did this for objects launched vertically. So famously, an object which is travelling vertically, suppose that you've got two objects which are the same with respect to density and shape. One is larger than the other. If they're launched vertically using the same force, which will travel higher, the larger object or the smaller object? Same force in relation to their mass. Which one will travel higher, the smaller or the larger object? Now, if we're Newtonians about this, we'll either say it makes no difference at all, or if we take into account air resistance, it will actually be the... Gosh, if we take into account air resistance, it'll be the larger object, won't it? Because proportionally this should be less air resistance. I think that's right. I'm terrible at physics, don't take my word for it. But if, on the other hand, if we're impetus theorists, we'll think the opposite. We'll make the opposite of the Newtonian prediction. We'll think that the smaller one goes up. I really should have looked this up and pretended to be good at physics before I started today. Sorry about that. And this, of course, is related to that famous experiment where objects were dropped from a tower all those years ago, where objects were dropped from a tower. So here's the thing. If you ask novices about this, what you find is that novices will give you generally incorrect responses. They'll give you responses which are clearly wrong, and they'll do so consistently. They're not answering at chance. They've got a wrong view about the world, a view about the world that was corrected in, I think, the 17th century, if I've got that right. Whereas if you ask experts, in this case students who've taken a physics degree, they're mostly going to give you the right answer. They're not perfect, but they're pretty much all the way there. But here's the interesting thing. Whether you're a novice or an expert, if we use representational momentum to test your predictions about the two objects, what we'll find is that in both cases, your representational momentum makes the wrong prediction. Your representational momentum makes the wrong prediction. It thinks that the larger object will slow down more quickly than the smaller object, even though it won't. Even though that's clearly wrong, and you could never have observed that. Why is this interesting? Because it tells us that the mistaken impression that people who haven't studied physics have, people like me, is linked to their broadly perceptual processes, the processes which are responsible for phenomena like representational momentum. We have a bunch of false impressions of the world, entirely false impressions of the world, things that we could not possibly have observed because of the way broadly perceptual processes work in us. Now, why would that be? Well, here's the thing. Any cognitive process whatsoever has to make some kind of trade-off between speed and accuracy. The faster you want something to be computed, the less accurate you can be. So, for example, if you're trying to reach a decision about what to buy or something like that, the faster you need to make the decision, probably the less information you can consider, or if you do consider lots of information, you won't be able to consider it in as much depth. And this principle, speed versus accuracy trade-off, applies to every cognitive process, and it's been known about for over a century and studied by cognitive psychologists for over a century. All cognitive processes involve a trade-off between speed and accuracy. So here's Henman, who did a very strange experiment in a way. He had just asked people to compare the length of two lines, where the lines could either be very different in length or rather similar in length. And he made a series of interesting observations, including that when people make a wrong judgment, that's generally a shorter judgment. So here's the thing. When we're thinking about cognition, a process can be one that occurs relatively quickly, or it can be one that occurs relatively slowly. When we're dealing with those relatively fast processes, and if we've got something broadly perceptual, that needs to move at roughly the speed that objects around us are moving, right, so that we can interact with them. Those perceptual ones have to be about as fast as things that we're interacting with are. The priority here has got to be the utility over consistency, and the way that that process achieves this is by limiting its accuracy. So it doesn't have a super accurate model of the physical, it has an impetus model of the physical. By contrast, when you look at a slower process, the priority here is to get more consistency. That's more important than just being useful. And you could have a more sophisticated kind of physical understanding. So you could have Newtonian physics or some kind of relativity. It just really depends on how long you're prepared to spend invested in your physical study. Why do I say this? Well, I say this because Kozletnikov and Hegarty say this. This is really their idea, but I think it's a correct idea. They say that to extrapolate on the basis of imperceptible forces such as friction and air resistance would require a time-consuming analysis, lots of different factors, lots of different information involving fairly complicated, intricate computations. But in order for our perceptual processes to give us the survival advantage, we need that extrapolation to be fast and not to consume too much in the way of scarce cognitive resources like working memory. That means effortless. The advantage, they say, of the impetus theory, so broadly Aristotelian way of thinking about the physical, is that it allows us to extrapolate objects' motion quickly without large demands on attentional resources. That's because, in effect, the idea of impetus, if I push something along, the idea is that it gains impetus from my push, and as it moves along it loses that impetus. What impetus does in effect is to wrap up together factors like friction and air resistance, gravity and the rest. They're all nicely wrapped up into a single variable, which greatly simplifies computations. And within a wide range of everyday cases, that impetus theory, the much simpler theory, will give you the same results as would a more complicated computation taking into account friction, air resistance and the rest. So for many ordinary everyday purposes, you've got nothing to lose by adopting the simpler theory. So what have I suggested so far? First of all, as Descartes noted, perceptual impressions of the world differ from how the world is. Modern physics is quite different from Aristotelian physics. Aristotelian physics was based on how people just thought the world was, on the basis of their broadly perceptual experiences. Secondly, the views that you have prior to any theory, your pre-theoretical views of the world, are shaped by broadly perceptual processes. It may be that you spent a long time, like Aristotle, thinking and reflecting on how the world is. It doesn't mean that those perceptual processes won't lead you to predict that the ball coming out of the spiral will move on a circular motion or a spiral motion, will continue to move in a spiral. However reflective you are, you're probably still going to get to that conclusion without modern physics. And thirdly, there's a good reason for that. There's a reason why the perceptual processes should shape our conception of the world in that way, and that's because they need to be fast. And in order to be fast, they need to trade off accuracy. But then, Steve, why is this relevant to our concern with ethics? You've just been talking about physics. What's going on here? Aha! I'm so glad you asked. Well, think about it this way. Suppose we applied Thompson's method or Rawls' method or the method of any of these ethicists to the case of attempting to discover things about the physical world. Right? Well, then we'd end up with a broadly Aristotelian approach to physics. So we'd end up with a broadly impetus-based theory of the physical, I suppose, at least if we were doing really well. And then, of course, we'd be unable to do things which involve moving outside of the situations that in our evolutionary history we've occupied. We'd be unable to do things like landing a robot on a comet. Right? Why is that? Because when you're dealing with robots on a comet, you've got to deal with variations in air resistance, because you're in a vacuum, and variations in gravity and all that kind of thing. Variations in factors which have been largely constant throughout humans' evolutionary history, at least in the situations that humans have been able to do anything about. So I think that's true. And why is that true? Well, that's because whether something seems obvious, even if you give it a lot of reflection, whether something seems obvious to you pre-theoretically depends on these fast, broadly perceptual processes, and those processes gain speed by sacrificing accuracy. So if you rely on how things seem to you, what seems obvious and what not, together with reflection but no deep theorizing, generating predictions, testing those predictions, repeating, rinsing, if you don't use, in effect, modern scientific processes, you end up limited to broadly Aristotelian view of the physical world. Okay, very good. But why does that relate to ethics? Well, here's the thought. If we apply Thomson's method or Rawls' method of reflective equilibrium in attempting to discover things about ethical principles, we're also going to be unable to deal with unfamiliar problems. Steve, what do you mean by unfamiliar problems? I'm glad you asked. Well, things like landing a robot on a comet is an unfamiliar problem in the case of the physical because it involves variation in factors that haven't varied over our evolutionary history. So air resistance on the whole has been, for practical purposes, kind of constant given what humans have been up to for most of the last tens of thousands of years. Likewise with gravity, yeah. The variations that humans have faced in gravity haven't been relevant to their practical projects over tens of thousands of years. Ooh, sorry, gone too far. So in the ethical case, an unfamiliar problem would be a problem where, again, the factors that vary are not factors that humans, practically speaking, have had to deal with in the tens of thousands of years of their evolutionary history. So you could imagine that we have artificially intelligent machines who move around the world and have preferences of their own. Or you could imagine that we have the possibility of transplanting brains from one body to another, or that we have the possibility of growing clones, or you could imagine the possibility of genetically engineering plants, or you could imagine that we could grow animals and farm them, not sort of in the ways that humans have been doing for thousands and thousands of years, but rather by putting them into very small cages in large factories and so on. All of these will be situations which are, I suppose, from an ethical point of view, quite unfamiliar. In this technical sense, it involves changes in ethically relevant considerations, where those ethically relevant considerations have been continuous for most of the tens and thousands of years of humans' evolution history. Or if they have varied, humans haven't been able to or interested in dealing with variations in them. So I think this is then quite straightforward. If we apply Thomson's method or Rawls' method in attempting to discover ethical principles, then we shouldn't think that we're going to come up with a theory that deals with unfamiliar problems any more than we would in the physical case. And that's because whether something seems obvious, even after much reflection, will depend on the fast processes, in this case the processes that shape our ethical senses. And those fast processes will gain speed by sacrificing accuracy. Those are fast processes which are tailored to the familiar situations and unlikely, right, because there's no reason for them, to be able to deal with unfamiliar situations. Okay, very good. So let me then try to finish the comparison here. So I'm thinking there are faster processes, there are slower processes. The faster ones tend to prioritize utility over consistency, whereas when you're thinking more slowly, you get for consistency over utility. If we think about ethics, relying on the fast processes, there is a model of the ethical that underpins them, and the work of philosophers like Thomson is providing us with a sense of what that model might be like. Right? The tricky thing is, just as Aristotle and followers of Aristotle have found, it's very difficult to come up with a consistent model here, because the processes that you're reflecting, or the principles which are encoded in the operations or reflected in the operations of those processes, are not ones where consistency is terribly important for. So it can be very difficult, but it can be done, right? Aristotle showed us that you can come up with a rather beautiful, elegant theory of the physical on the basis of informal observation and reflection alone. Now, here's the interesting thing though. Suppose that we try to move away from that. What would we come to here? What would we come to here? What's the alternative? Is it, as Singer or Green would say, something like a form of consequentialism? Well, why should we accept that? That's not obvious at all. In the case of physics, we've got theories that generate a whole range of readily testable predictions and a fairly large enterprise of testing those predictions. So we've got an alternative basis for accepting theories in the case of the physical. In the case of ethics, we don't seem to have any comparable reassurance there. So it doesn't seem like we should necessarily plug those in here, or at least that would be very controversial. So here, just here, the analogy, I agree with you. You saw this coming, yes, okay, all right. Sorry, you saw this coming half an hour ago, I apologise. Here I think the analogy breaks down. We don't actually know what to put in here, or I don't know what to put in here. Right, where am I? Well, you would say to me, Steve, where's the argument? And there isn't one. This is a preview. And what I've offered you is a view which is entirely unsupported. So I don't expect you to accept this view, and I'd be horrified if you thought the view was correct, because I've given you no reason for it. There's no reason to accept this view at all. That's what I intend to do in the rest of this lecture and the next, slowly and in a sort of really circuitous way, is to provide a defence that this is a correct view, as opposed to the various other views that people have offered. Why is the view relevant? Because it has some consequences. The first consequence is this. We've been asking whether scientific discoveries could undermine or support ethical principles. And I think the answer to that question is no, they could not. The reason for that is very simple. Scientific discoveries about physical cognition do not undermine or support discoveries about the physical, right? We don't support or reject theories about the physical on the basis of discoveries about physical cognition. That would be unexpected. Now, I'm not saying it's completely impossible, but it's so bizarre that it wouldn't really be, it's not really a possibility, I think, that we need to discuss in lots of depth. I think we should take the same attitude with ethics done properly. I think if we're doing ethics properly, if we're not relying on things which we know are going to give us resources that are only suited to dealing with familiar situations in that technical sense, then we should not think of discoveries in moral psychology as having any relevance whatsoever here. No direct relevance whatsoever. Does that contradict what I said about Foote? That's a very good question. I'm glad you asked that question. So what I said when we were discussing Philippa Foote and her method of trolley cases was this. If Foote's method of trolley cases works, then there's a direct role for discoveries in moral psychology to play in ethics. And I stand by that. If we go with Foote's method, then I think there's a fairly clear way for discoveries about moral psychology to work. But what I'm suggesting here is that we shouldn't follow Foote's method of trolley cases. I think that's a mistake. Foote's method of trolley cases, if you remember, involve thinking about why it is that people make judgments about this situation or that situation, judgments based on informal observation and reflection, rather than any attempt to be systematic in their thinking, any more advanced methods, and then try to work back from those to ethical principles. And I think that that's about as mistaken as it would be in the physical case, so that we shouldn't do that. So what I'm saying here is not inconsistent with what I suggested before, as long as you're careful about that conditional. All right, good. Now I know many people disagree, so many people here will be much more sympathetic to the idea that Foote's method or Thompson's method, which I think those are different, of trolley cases is the way to go here, and that's fine. That's absolutely fine. You've just got to argue your point, just as I've got to argue mine. I haven't done that yet. But there's another question, which is, could scientific discoveries change how humans do ethics? And I think they probably could. I think scientific discoveries about moral cognition show that moral cognition works in ways analogous to some of the ways in which physical cognition works, and that the two things are limited in the same ways. And I think that could change how we do ethics. So here it's almost like things are backwards. I think in the case of the physical, what happened is that people for a long time pursued the kind of Aristotle-Thomson method of doing physics, and then lots of interesting physical theories came along, and there was a big kind of problem because people were torn between thinking, gosh, it just seems so obvious to me that that thing was going to move, the small thing is going to move faster, slow down less than the big thing, right? Or the big thing is going to drop faster than the small thing. It just seems so obvious to me, but the theory tells me something else, right? It seems so obvious to me that the world is like this, but the theory tells me something else. How do I deal with those two things? And it's only much later that we discovered things about physical cognition. I think what's happening in the case of ethics is almost the opposite. We don't have a systematic way of doing ethics in the way that we have modern scientific methods, but we do have some discoveries about the moral psychology, the underlying abilities, and those underlying abilities already tell us that the way of doing ethics based on how things seem to you on reflection can't actually get us to truths about ethical principles.